types of reaction, okay? Organic reactions to be specific, okay? We're looking at organic reactions. Now, in organic chemistry or in organic reactions, most of us are peculiar with what we call addition reaction. We also have heard about what we call substitution reaction and also elimination reaction. So, for the sake of this video, I'm going to talk about it, but we are going to see more of them when we start looking at functional groups and some homologous series, okay? So I'll just briefly talk about this reaction, what it is, how it happens. I won't go deep into the mechanism because the course outline does not entail that we'll talk about the reaction mechanisms, okay? I will just talk about the reactions, the basic understanding of these reactions and where it happens and when it happens and what can initiate these reactions and then the rest of them, okay? So I'll start with addition reaction. Now, if you notice that addition reactions are peculiar to unsaturated compounds, right? With the likes of benzene being an exception, okay? Even though benzene is unsaturated, yet benzene do not undergo an addition reaction; it undergoes a substitution reaction. Okay, why? Because for benzene, it stands out due to the fact that it is being stabilized by resonance. So there is no need for it to, the pi electrons are delocalized, so there is no need for it to further undergo a reaction addition wise to destabilize that delocalized electrons or the stable conjugated pi bonds. Okay, so but naturally other unsaturated compounds undergo addition reaction. So this addition reaction simply means you are adding two atoms. You're adding two atoms to the point of what? Unsaturation. For example, if I have an alkane, let's say something like this, I use an alkane, and you are undergoing an addition reaction. Let's say we are adding HX, or we are adding any molecule at all into this, okay? So this simply means that for the fact this guy is unsaturated with double bond, I will add these two molecules to these 2 points of unsaturation, okay? So the end point of addition reaction is to, at the end of the reaction, this unsaturated compound will become saturated, okay? So what happens here is that we are going to add this molecule. These two molecules we brought here, we can add one here and then add the other one here, okay? So that we can have something like this. So this is what we mean by what? Addition reaction. So you are adding a species or a molecule to the point of unsaturation, okay? So this is an addition reaction. So addition reaction is not only seen, okay, in this kind of compounds. You can also see an addition reaction in a carbon to oxygen double bond like this, okay? So addition reaction can take place whereby you add the same species. Let's say we are adding HX, this species to this guy, okay? So you can also have something like this. Oh, you add your H here, then add your X here, then you still have this. So this is another point of an addition reaction. So these are addition reactions, but inside addition reaction, we have several types of addition reaction, okay? We can also have electrophilic addition reaction or a nucleophilic addition reaction, which I don't want to go into deep learning because that is not what the outline is talking about. So the outline wants us to just know the basic, just understand the concept behind this thing, so we can just actually use it to predict some reactions, okay? For the mechanism is not part of what we are doing here. The mechanism is not in the scope of this study, so I won't go too deep to come and start showing you the reaction mechanisms and how this happens, okay? So but generally an addition reaction involves the addition of species to the double bond, okay, to a double bond to and to an unsaturated point. So if you notice here, at this unsaturated point, some things were added, okay? So if I add the hydrogen here and I add the halogen here, I will then clean the double bond, okay? So the end point of an addition reaction is to convert that unsaturated point to what? A saturated point. So this is an addition reaction, this is an addition reaction giving this product. So for addition reaction, you are not losing any molecule, okay? Nothing is lost or nothing is exchanged. We just added something to the already existing molecule. So that's what we mean by what? Addition reaction. The next is substitution reaction, okay? Now, the difference between substitution and addition is that for substitution reaction, you are replacing a molecule in that compound with another molecule or another atom, okay? I repeat, the difference between addition and substitution is that for substitution reaction, you are removing something from the molecule you are trying to undergo a reaction. You are removing something from it and replacing it with something else. Okay, so substitution reaction is simply a replacement reaction. That is, you are replacing an atom with another atom. And this reaction is peculiar to saturated hydrocarbon. Okay, saturated compounds. Saturated compounds have tendency of undergoing a replacement reaction. That is, an atom in that molecule will be replaced with another atom in that molecule. For example, watch. Let's say we have, let's look at halogenation of alkane. Okay, as an example. Remember, I'm just looking at an example. In reactions, okay, alkanes undergo halogenation. That is reaction with what? Halogens, right? So if I have an alkane, let's say I have an alkane RH. This is an alkane, I hope you know, this is an alkane. If I have an alkane RH reacting with, let's say, a halogen X2, I don't know the halogen, let's say any halogen, chlorine, fluorine, iodine, but it's a diatomic molecule, right? Now, this reaction, normally, this kind of substitution reaction takes place in the presence of a light, of a UV light, okay? So the UV light, let's use UV light as a case study, okay? Now the UV light, we are going to look at the step or the mechanism for this halogenation, okay? When we get to alkane, we look at the initiation, propagation, and the termination stage, right? So now, for this reaction, what happens here is simple. The halogen, one of it, out of this X2, one will substitute this guy. Hydrogen will leave and one will replace it. So what I will have here is what? Rx plus that one, this one that now left will now pick up the other X here to form what? Hx. Okay? So this is just the general form of how halogenation takes place. Not just in alkane, also in alcohol. In alcohol, halogenations also, substitution reaction also takes place. For example, if I have something like this and I am reacting it with, let's use thionyl chloride, okay? Thionyl chloride dissolved in pyridine. This is the solvent for this. If you have something like this reaction can go. What you are going to have is simply, you have your R. The chlorine will come and substitute what? The OH. I'll have Cl plus, everything here will form something else. I have SO2 plus HCl, right? Think something like that. Okay, something like this. So looking at this reaction now, you will see that what is happening here is a substitution reaction. Chlorine, one of it from the thionyl chloride, will replace the OH to form this. Okay? And also, everything here will now form some of the outside and what? HCl. So at the end of this reaction, what you are noticing is that the reaction is a replacement. Unlike addition, that you are adding something to an already existing molecule. But for this one, we are removing something from it and replacing it with another thing. So this is what we call substitution reaction. So there are several types of substitution reaction, okay, which we are going to talk about briefly towards the end of this video. We have what we call the SN1 substitution reaction. We have the SN1 substitution reaction. We have the SN2 substitution reaction. So I'll talk about these two reactions towards the end of this video when I'm done explaining this one. Okay, so now when we talk about substitution reaction, just like I've told you, they are peculiar to saturated compounds who do not have a double bond or a triple bond. They are all single bonds. Okay, so saturated hydrocarbon can undergo a substitution reaction, but the mechanism depends on the molecule, or it depends on so many factors. Okay, so but the mechanism can either be an SN2 pathway or an SN1 pathway. Okay, so quickly we are going to look at what this SN1 and this SN2 reaction is talking about.